Hello, members. In this lecture, we are going to discuss a number on t-statistic. So the guiding question says, a fertilizer mixing machine is said to give 12 kilograms of nitrate for quintal bag of fertilizer, and we are told that 100 bags are examined. So there are 10 bags, each weighing 100 kilograms, and they have been examined. The percentages of nitrate per bag are as follows: 11, 14, up to 12. So we are being asked, is there any reason to believe that the machine is defective? The value of T for 9 degrees of freedom is 2.262. So this involves hypothesis testing. So if it involves hypothesis testing, we need to understand what is the null hypothesis and what is the alternative hypothesis. So if it is said to give 12 kilograms, so it means 12 kilograms is going to be our sample, our population mean. And then we shall be required to calculate for the mean for this sample and see if the hypothesis tells us, after proving, if the hypothesis tells us that there is a reason to believe that the machine is defective. If it is defective, that will be saying that the values that were measured per bag for nitrate are always close to 12, and then we shall be able to decide. So that means, since we are talking about a mean of the population, we shall say that the null hypothesis nu is equal to 12. And then if it is defective, then it does not give nu equal to 12. So therefore, the alternative hypothesis becomes nu is not equal to 12. So this is going to be a two-tail test. Okay. So how do we proceed? Since it is a t-statistic with, of course, n less than 30, okay, so our t value will be calculated from the sample mean minus the population mean divided by the sample standard deviation divided by n. So after getting our t-statistic, we shall be able to compare it with this critical value, since this is a critical value at degrees of freedom 9, which is n minus 1 equal to 10 minus 1, and this is equal to 9. So this is where they got the 9 degrees of freedom. So from there, we shall check on our tables and then be able to look for the critical value. But here, it has been provided for us. So our task is to calculate the statistic and compare it against the 2.62. So we proceed. How do we get the x bar? So the x bar, we shall add up these values, so that will be sum of x divided by n. So when we sum the 11, 14, 13 up to 12, we get 125 divided by 10, because n is 10, and this gives us 12.5. So when we get 12.5, remember our sum of x is 125. Okay, so from there we also need to look for the sample standard deviation. So the sample standard deviation, the formula is sample standard deviation. The formula will be sum of xi minus x bar squared divided by n minus 1, everything under root. So we have to first look for the sum of the difference of these squares, or the sum of difference squares. Okay, and from after getting that, we can divide it by n minus 1. So what is xi minus x bar? So I will get x minus the mean, the sample mean, which is 12.5, 14 minus 12.5, 13 minus 12.5, up to the last value, 12 minus 12.5. So what we get here is that value. Then from there, we square them. So when I square, these are the values I'm supposed to get. And from that, I need to get the sum of xi minus x bar, everything squared. So what I get is 10.5. So that means our sample standard deviation will therefore equal to 10.5 divided by what is n is 10 minus 1. So everything to the power half, and our sample standard deviation will equal to 10.5 divided by 9. This is the same as taking square root of 1.1667, and this is 1.08. This is two decimal places. So what next? We have to calculate for our t value. So let's look for the t value. T will therefore equal to 12.5 minus the hypothetical mean, which is 12, okay, for the population, then divided by the sample standard deviation, 1.08, divided by the square root of 10. So this is 0.5 times square root of 10 divided by 1.08, and our t value is 1.46. Okay, so I have 0.5 times square root of 10 divided by 1.08. So 1.464. This is 3 dp. So what we do, we are going to compare. So compare your t statistic against the critical value. T CV equal to 2.262 at degrees of freedom equal to 9. So I'm going to draw something like a number line. This is my 0. This is our t value, which is 1 point. Okay. Okay. So since it is, we said it is a two-tailed test. So what we are going to do is to draw. Okay. So the 2.262, when we check at the degrees of freedom 9, okay, it represents the significance level of 5. Okay, so it represents the significance level of 5. So what we do, that means the alpha value here is of 0.025. The alpha value here is of 0.025, meaning this is rejection region. Okay, so at that level we have at the 0 point. Okay, if we go with the one-tailed test, we see that is the same as the 2.5 level of significance for a one-tailed test is the same as the 5% two-tailed test as for 5% level of significance. So what does that mean? They are going to take the same value. So if they take the same value, we are saying this is 2.262. And where is our 1.4? So our 1.4 is behind. 1.464. So what does this mean? Remember, this is the TCV, okay? And this is our T statistic. So that means that the T statistic is outside the rejection region. Mhm. What does that mean? It means we fail, okay, we fail to reject the null hypothesis. So if we fail to reject the null hypothesis, um, there is no reason to believe that the machine is defective, because the mean that we hypothesized, which is about 12, is the same mean, okay? Is the same mean that the machine was set to give. And so if we cannot reject the null hypothesis, it means there is no reason to believe that the machine is defective. So that's how basically we can answer this problem.